Hello, everybody, and welcome to today's Anti-cast with Markus Schober. We are going to be investigating some insider threats with Windows forensics. Very excited to have you here, Markus. Are you about ready to get started, my friend?
I am. Yeah, thank you.
Awesome. We'll be in the backstage, listening, collecting some questions, and I'll come and join you when there's about 5 or 10 minutes left, and we'll go over some of those questions and take it from there. So you are more than welcome to get started, my friend. I'm going to head to the backstage. Good luck and have fun, everybody. See you in a bit.
All right, appreciate it. Thank you so much, Zach, and the team for having me back. Some of you I even know in person based on what I see in Discord. Awesome to see you, everybody. Thanks for joining. I'm back with some Windows forensics. As you know, this is kind of my specialty field, so I'm happy to, share every once in a while something that I think is like cool and worth it to share and get into. So today what we have is applying Windows forensics, and in this case, more specifically in terms of something along the lines of an insider threat. And yeah, just go ahead with some introductions and some introductory topics, and then we'll do a live demo, of course, for most of the time as always. All right, so first things first, for those who don't know me, just a quick introduction. My name is Markus Schober. I am an instructor at a variety of different types of Antisyphon conferences, virtual conferences, and for the most part, I'm also doing ransomware attack simulation and investigation workshop at the Wild West Hacking Fest. I've been doing this for several years now, and it's always been amazing and fun and just awesome to be part of this community, of the group. But my background is in software development and then incident response. And after having worked in incident response for a number of years, digital forensics, incident response, I saw that there's some things that can probably be done better in terms of training, so making realistic kind of consulting training services. And this is how I've started Blue Cape Security, which is my own training company that I started a few years ago, where we provide training. One of those is, one part of this is also working with Antisyphon. Some of the courses are there, and also the Wild West Hacking Fest. So this is about me. Again, there's a lot of courses out there here and there that you might have found or seen about that I've done. So yeah, Windows Forensics course right along the lines of what we're going to be doing here today. But everything I want to do is obviously, as you can tell here, very real world inspired. So it's not like, any artificial kind of scenarios or anything. Everything comes from based on what we've seen out there. Let's try to, emulate, simulate it, and just go through this just as if it was a real case. And this is what we want to be doing today as well. So first things first, let's start off with Windows forensics. Now, who is even, familiar with Windows forensics here? Just want to get a feel of the audience. I know I'm going to get a lot of memes probably in this case now, which is awesome, but you feel confident, yes or no, in terms of Windows forensics? Do we have experts here? Kind of, sort of, not really. That's exactly the meme I was expecting. Yeah, so some do, some more or less. Okay, so some people, Windows forensics, some people get to do it every once in a while when it's needed. Some people get to do it all day. DFIR, incident response, and digital forensics. It's often the term that goes together, which are technically two very different disciplines, though. So yeah, I just wanted to know because for some people it sometimes looks intimidating, right? Or for some people it looks easy, and actually there's maybe even more behind it. And this is why we've been talking before that a little bit in the pre-show banter about, how to be competent or confident. And this is what I wanted to get into. I just also want to step back a little here and see and tell everybody how to get up to speed on this, right? Because it's not just about, diving into the artifacts and then this is it. I want to also get kind of, show you how the typical learning curve, goes in terms of learning probably anything really. And this especially is very well represented by the Dunning-Kruger effect, which many people have probably heard of. You can be confident and you can be competent, but in the beginning, it often starts with things feel overwhelming, right? You don't know exactly like where to go, where to get started. You're not competent at all. Then you kind of, do your first thing, you learn something, you go through a course, you might have done like, CTF or a challenge or something. Then all of a sudden you feel like, well, I am very confident. I know everything. Everything is awesome, but not really competent, right? And this happens a lot. Like this is just to show that There's so many phases we go through, and this has happened to me with my team when I used to work as an incident response consulting team. All these people that came on board first was very intimidated. Then they kind of thought they knew it all. Then they slowly realized, oh God, there's more and more and more with more cases that we're working on. Then slowly you start kind of, getting better and better and more experienced. And at some point, ideally you get like guru status, like, highly confident and highly competent. But it really comes over time if you keep doing things, the right way. And this is just what I want to throw out there because that's kind of how it goes. Sometimes you have to spend more hours to get better at things, at actually seeing new things too. So this is important. I just want to get into that because what it takes to perform Windows forensic investigations is not just technical knowledge. It takes more. So first of all, why is it hard when we perform Windows forensics investigation or forensic investigation in general? Investigations usually start with uncertainty, not with the answers, right? So first we need to even think about what's the goals, what's the objectives of this case, because if you start forensics without a goal, that's hard. And this is why it's oftentimes different. And I don't want to say, CTFs are not necessarily bad, but oftentimes you get questions asked in terms of what to look for. And that's not the case in terms of real world investigations, right? You get maybe a disk image, memory image thrown at you, and then, well, good luck figuring something out, and you don't have a lot to pull on. So this is why it's open-ended, different tools, different types of evidence, and we need to piece it all together. And ideally in a guided, like ordered, like structured fashion. And why is it important to consider that? Because not all cases are the same. And here's just a list of a few things that I put together. But in the real world, you are facing a variety of different types of investigations. So for example, if you're dealing with an insider threat that we're going to be discussing today, things might start off very different in terms of how you approach the investigation, right? Insider threats means somebody might have had access, legitimate access to your systems, to your tools, to your applications, or to your resources, and then just maliciously using this for their, to their advantage. But that is hard because that doesn't mean there's any malware involved. That doesn't mean there's anybody broke into things, right? This is like somebody was probably even interactively logged on, which creates a whole different number of artifacts to investigate than if somebody wasn't logged on interactively, first of all. And secondly, it might even, with malware and ransomware, you have a whole number of tactics, techniques that you are typically looking for that might be more or less interactive artifacts that you will find based depending on how the threat actors were using and which tools they were using. Non-interactive, PowerShell executions, lateral movement, all these kind of things. Not so much with insider threat because there's no lateral movement in the sense of malicious activity that would stick out. APTs, similar thing. There's very unique cases sometimes more stealthy, different objectives. So we need to consider that as well. And then you might have denial of service attacks, and then all of a sudden things are not as quiet at all and not as stealthy at all, and you have to deal with a whole different approach in terms of how to investigate it. Same with social engineering, right? Somebody's getting tricked into doing something they're actually authorized to do. How do you actually find that out? When supply chain attacks, that just came up because sometimes things start out of nowhere within an application you never thought about. It's like thinking back of the most recent supply chain attacks, or even years ago with SolarWinds, which kind of ruined my Christmas a few years ago. So that was some of those cases where it's just important to show that investigations take some kind of mindset that we have to, if you have experience, kind of automatically kind of adjust based on what we are looking into. Now, it's not always just about the knowledge or the technical knowledge, like I mentioned before. Some of those kind of things that you want to be aware of is also that you want to be tool independent, or at least be able to carry out an investigation with different types of tools and different types of artifacts and different types of evidence available. Not every case is the same, especially if you work in consulting, right? You go from environment to environment, from case to case, and you see different tools, different types of telemetry and logs and artifacts. So it's really it depends a lot, and you need to just better understand what you want to get out of it and how, instead of having you be guided by a tool. So that kind of comes with experience. Same thing for pattern recognition, right? If you just look at things many times over and over again, it kind of comes naturally that things kind of start smelling You know, you can smell when something like looks wrong or odd, and that's I've seen with some of my most experienced colleagues in the world out there that have, you know, gotten into cases and they just looked at like base 64 code and they could even tell which one was bad and which one like was you know, associated with which like threat actors because they've seen enough of those. So that's kind of like what I'm talking about. And then contextual awareness, and this is another thing. If you want to, you know, if you want to get more into forensics, for example, or anything really, but in this case, Windows forensics, you can take a course and you can, like, you know, work on an image and everything, but the contextual awareness usually is that within a corporate environment there's a much higher complexity of things, right? You have way more tools, applications, logs, user logging in, logging on, applications doing the thing, automation. Everything is just much more complicated. It's not just as clear cut as it oftentimes seems to be, especially if you're dealing with an environment compromise. Like, there are so many different variables, and you kind of, you know, need to know if like what is like legitimate, what looks malicious, and what might look malicious in certain environments. So it always depends. It's always a little different. So that's why it's, you know, some things are sometimes challenging, and it's not always just the technical knowledge that is needed. But yeah, when we conduct investigations, at the end of the day, what we try to find is evidence, right? We try to find evidence of something did or did not happen. That's mostly what we do when we try to, you know, perform digital forensics analysis. Now, how do we approach the investigation generally? Not just particularly in terms of insider threat, but generally you have context and questions, right? You want to know how far should you even take the investigation, right? Sometimes the problem that you see is people keep digging down into rabbit holes and they just spend time and waste time forever, and it might not lead anywhere. But, you know, that comes with experience, and sometimes, you know, and oftentimes has something to do with basically, you know, asking the right questions and having the right objectives in the beginning. For example, when you have, you know, potentially compromised environment, you might want to know right away, are the attackers, threat actors still here? How did they get in? How can we contain? Which systems were affected? Did they steal any data? Which is one of the most, you know, first questions that your legal team would ask you. And in that case, we would turn that into, you know, okay, what are the objectives? So for us, that means we would, for example, start trying to identify, if we map it into, you know, MITRE ATT&CK tactics, initial access, how did they get in? Are there any persistence mechanisms? What did they execute and how? Is there any lateral movement? Which systems were logged on to and from? Exfiltration in terms of data. Was there any data stage copied, exfiltrated? Impact that often mostly goes into, like, you know, detonating a ransomware, or deploying ransomware. So these are the things, you know, and this kind of puts it already in kind of a structure where, you know, okay, let's find this and this and that evidence, and there might be some artifacts and, you know, some evidence that we can use to do so. So let's start a forensic investigation. Some people that have, you know, seen my courses or trainings before, they might have seen this slide, but it's, you know, this is the standard. So the incident response lifecycle, the forensic lifecycle by NIST, the forensic process is not just about the analysis. Most importantly, it actually starts off with the collection of the evidence. And the collection of the evidence is the most important part, because if you mess up collecting the evidence, you don't have anything to analyze and the case is done. So that's why I just keep, you know, harping on, make sure that you have a data collection process in place for any kinds of types of scenarios or environments or systems, because that is the most important part. And honestly, from, you know, experience, most of the time, this is where things go wrong. Like, if you just ask a random IT person to collect a disk image or something from a cloud environment or logs from somewhere, or from like a remote employee, for example, those things oftentimes take more time than needed. And it, you know, sometimes, you know, basically messes up the entire case because you don't get the evidence you need, or you don't get it in time. And time oftentimes is critical. So you need to have places and processes in place in order to understand, okay, for a given case, what are the data sources that we might need in order to, you know, identify the data sources in order to perform an analysis on those. Then we have, you know, things such as best practices following the order of volatility, such as, you know, volatile data first, memory, then disk images, then logs, maintain chain of custody, verify integrity, especially if there's potentially like legal implications with those cases. So best practices for sure. Having those processes in place is awesome, because that would allow you to quickly collect, maybe even then examine, such as parsing and processing the collected data in the next step automatically even. So you actually just collect and you wait and you have parsers in place so that you can then at some point just perform analysis on the output. And the output, the analysis can be based on, in our case, we're talking about Windows systems, so Windows memory images, Windows disk images, and there's artifacts in there that are very well known in the forensic world that you can use to ideally identify evidence of something did or did not happen. And eventually, at the end of the day, the evidence is being put into reports, or at least some shape or form of documentation, sometimes timelines. Not everything needs a report every time, but it depends on the case, of course. So this is what the forensic process would look like. Now, what are kind of the areas that we will look into in Windows forensics, for example? So here are some sources of evidence. Of course, if you can, data from the memory, volatile data is extremely helpful, especially if you have virtual machines. Just suspending the virtual machine and grabbing the memory can be a huge win, because that's where volatile data is stored, where you can get still some network connections potentially, command line things, command lines that were run, processes that ran, files that were loaded, all kinds of things. So really, there's a lot of stuff in there in the memory that can get you a lot of information that you wouldn't be able to get otherwise so easily. But if you only have the disk, or if you add the disk as well, there's a bunch of main sources that you need to be aware of. First of all, there's the disk image. The Windows system runs on a file system that depends on the NTFS file system. So the NT file system, there's a number of features that it brings to the table, but one of them is, for example, handling when a file has been created or modified or accessed or deleted. This is handled by the NTFS, not by Windows itself. Windows relies on the NTFS. And the NTFS, of course, has a number of files that you can use to look into these things. If, for example, when files were created or modified and sometimes even deleted. So that's where things such as the NT, with the MFT or the user journal come in handy. Then there's the Windows registry, which is basically the main place of where a lot of the Windows configurations are being stored. A great source of artifacts for us in terms of forensics, because that's where we can see when certain things applications ran, what they were storing, and things along those lines. Event logs, some event logs in Windows are useful for security or for analysis, not all of them, of course. And then there's a whole lot of other Windows artifacts that are mostly used, built for increasing the user experience, making things run faster in the UI, not in the UI, background processes, keeping track of things. And all these things is what we can use technically in forensics to reverse engineer and figure out what actually, if there's evidence on it when something did or did not run. Now, there's a lot to remember, and there's a lot that you would have to keep track of. So when it comes to Windows artifacts, one thing that I keep as a guideline here is a cheat sheet. Some of you might have seen this. There's the Practical Windows Forensics cheat sheet out there. I can actually post it in the chat too. I used it as a guide all the time because it tells you where you can, what are the artifacts that you want to be looking for in terms of, all the way from data collection, then into registry hives. What are some artifacts for evidence of execution, of persistence mechanisms, all these things. So cheat sheets for the win, right? This is something that's out there on GitHub, actually, that I've built and, as part of the trainings. So this is a good one. And then next, when you perform the analysis and when we document things, there's different ways and shapes and forms to do so. A lot of times when you perform forensics analysis and incident response, you create timelines, and there's different shapes and forms. There's not really a standard out there. Best practices, what you've seen, especially in those, more, high-class kind of, incident response teams, that they have lots of processes in place where at the end of the day, things get put into a timeline. So when you document, take notes and everything, at some point you start shaping up a timeline, chronologically ordered, where you can see when something happened, where, how, and so on, based on which artifact, which evidence, and so on. One thing, so there's only one company so far has posted or published a timeline spreadsheet at this point, which is CrowdStrike. So I'm going to post it in here too. It's pretty awesome. It's this version that you see here is basically my simplified version of an incident tracker, which is a huge spreadsheet where you keep track of evidence and you keep track of timelines and keep track of IOCs and things along those lines. So that might be pretty helpful. I've been using these kinds of templates for most of our investigations. All right, I guess we are ready for let me see, ready for the investigation. Let me jump into this lab here real quick. With that being said, jump into my lab, and then we take things from there. What we are gonna do here is using a case that I've prepared and I've ready available on our site. We just recently released a number of investigation scenarios for digital forensics and Windows on Blue Cape Security. So this is a case that I wanted to share with you. This is a case they call 4200, and this is a case that evolves around an insider threat. And there are some interesting findings around this one. And this is what we're gonna be doing now, investigating this particular case. But the first and foremost is, what are we actually dealing with? So let's get this case introduced and started. This case is about a user that on March 12th, the user is called Luke Evans in this case, random name, COO, at a fictional company, which all our scenarios are run under, which is Terra Nova Technologies. So basically on March 12th, Luke Evans submitted his resignation. But there's suspicion that this person has been collaborating with a competitor, and there might also be some proprietary information involved. So what we want to do is figure out if there's been any illegal activity prior to his resignation. And this is literally based on cases that I've worked on in the past as well, where an executive leaves and the company really needs to figure out if there was any confidential information, intellectual property taken or shared, and then you just basically dive into this. So what we know is there's this person with a VM and the IP address, and we have a disk image. Now the investigation starts with, well, do we actually, what are the goals? What are the objectives? Illegal activity is one thing, but we need to be more specific. So in this case, figure out if there's any suspicious user behavior, including web browsing, documents, creation, and movement, and so on. Let me see if there's any files that may have been copied, staged, or stolen. Data, so basically a data theft. And then see if there's any anti-forensic activity. So did this user maybe potentially use anything to hide or disguise the kind of activity they were doing before they resigned? So the approach is perform disk analysis and figure out how to answer these questions. Alrighty, so in this case, there's a VM associated with this course, which I have already started up all through the browser. And here we are. This is the case. And when we get started with the analysis of a case, we need to keep track of things. And I've mentioned the incident tracker before, or like creating timelines. And this is what I will be pulling into here occasionally as well. I have a timeline template here, which some pre-filled data that we will be going through. And what you're usually starting off with when we're looking into investigating a system is, first of all, we want to have the system information, right? How do we get the system's host name, the operating system, the IP address, when this operating system was installed, shut down, was antivirus disabled or not, which accounts have existed on this user, on this system, interactive accounts, so profiles in this case. And then we start building a timeline. So we do not have time, of course, to go through every single one of these artifacts and how to find those. So we need to skip a few. But first things first, if we have a case, I have cases right here, what you typically get is a disk image, and there's a VMDK. So this VMDK now consists of basically the virtual disk of this system, which has windows and artifacts and everything on there. So we need to mount it and then parse the data from it that we need. In order to mount it, there's a few really handy tools out there. One of them, the best one out there is, in my opinion, Arsenal Image Mounter, because it can do a few things that others don't do so well. So I have mounted this image with Arsenal, and it's on the D drive. And so now the D drive, you can see now we have access to Luke Evans disk image right here. And it even exposes us to some files, but not all of them, the ones that we need. So now we need a tool that actually can collect all these files that are not visible to us. For example, there's the NTFS files, right? There's out here in the root, sometimes you have the MFT and you have the USN journal and so on. So for this, there's a number of tools and ways available. My go-to is always the Cape parser. You might have seen this in previous sessions before, so I'm not gonna go too deep into this. But Cape basically allows you to point to a disk image, to a mounted disk image, and then just say where you want to store the output. And then you can say which artifacts you want to collect. It could be individual artifacts like all of these, right? Or it could be like a compound target artifact is what they called here, which means, give me like the top dozen or 2 dozens of artifacts that we need. So for example, what I like to do often is just go, say, use the compound target here called Cape Triage, because this one consists of all of, let's see if we can see this here, these kind of artifacts. It would collect event logs, registry hives, scheduled task information, and probably the top 20 artifacts that are out there. So it would collect all of these things, and then it would store it for us somewhere so we don't have to mount the image every single time. Now, from there on, we can now then start parsing the output. What we have as an output is actually something like this. We will have a triage collection, which starts with the drive letter where it was under. And now we can already see we have the NTFS artifacts that we want, especially the MFT. And then we have the most important files available. And if you go in Windows, System 32, for example, we have the Windows event logs, and it parsed out scheduled tasks, and it parsed out the registry hives and so on, right? And we even have like same thing for user information, things like here, all these users, we have some of the artifacts we need. So that's great. That also gets us started, and we need to then parse those in order to be able to read them, right? Because some of them are log files, some of them are databases, some of them are like binary files. So there are some parsers out there, and most of you have probably heard about the Eric Zimmerman tools, my favorite parsers. So Eric Zimmerman has written a whole lot of parsers for individual artifacts on Windows. Now, if you want to know which artifacts we're going to be using and talking about, again, I recommend using this cheat sheet, because that's where things might be more clear, right? You can see, hey, if we want to find out information about the computer name, it's under the system hive, and then it's under control set, the registry hive, control set, control, and then there's a key called computer name. You can find the Windows version under the software hive, Microsoft Windows NT current version, time zone information, network IP address information, things along those lines. It's all, this is what the cheat sheet is for. And there's even some user information. And for about some of those, we're going to talk about some of those today when it comes to the insider threat investigation. So if you want to learn more about the artifacts, or if this is new to you, feel free to take a step back, check out the artifact, or maybe even the training. We'll go over these a little faster here. So if you want to parse these, and if you want to apply those parsers with the data that we have just parsed out, Cape also has one more option, which is amazing. You can run modules. So based on the output that we collected, you can actually apply those parsers right away in one go, which is, for example, here, you just pointed to the output, and then you apply the Eric Zimmerman parsers, and it would apply all these sub-parsers to the output and then give you CSVs as an output. For those who are familiar with Eric Zimmerman or most forensic tools, basically the output is always CSVs, right? So with that out of our way, let's see what the result looks like, because I've already prepared that, of course, because otherwise that would take some time. And if I jump into my case, you can see, so again, here's the triage and then collection. And here is the output of the parsers. So this is what Cape parsed out automatically by applying the Eric Zimmerman parsers. It did bucket those into different folders. So you can see we have one CSV file that includes all the event log information, all the event logs in one CSV file, right? This is amazing. You can just go through these, parse them, look for things, grep through this, with command line if you're looking for certain things, looking for event IDs, the analysis that makes it much easier. And then there's a number of other categories that it actually parsed out for us. It's file folder access. And here's getting really interesting. As you can see, things are basically assigned to particular users. Now, there is some more advanced, or some not advanced, but some more artifacts that you might not be familiar with. And we will elaborate on those in the next few minutes. But for those who are familiar with those artifacts, this might sound, pretty straightforward, right? We have, for each user, we have an anti-user and a user class registry hive. And for each user, there's some good amount of information in there, such as what the user, the documents that the user opened, the documents that they stored that we're browsing or opening, saving, modifying, or for example, the file folder structure that they were exploring through their file browser. This is in the user class hive, and all these things. LECMDs, link files. There's like a lot of artifacts that can prove evidence of a user doing or accessing or executing something, which is all in here. And same thing, for some of those other ones. But first things first. Now, once we have our timeline, our template ready, and let's say we have collected the system information from those registry hives, we can now say, okay, the first thing that I would think about is if this user really is like, the CEO, COO, I would expect them to have interactive access to their system. And then I need to see what they were doing while they were logged on, right? So first of all, I would see in event logs when were they logging up, when were they logged on? And secondly, what did they do when they were logged on? So while I might not go through the logons first, because that would take up the rest of the session, we can see what they did by exploring some of those artifacts. And one of those artifacts, the first one we want to look into, is something called Shellbags. Shellbags is an artifact that gets traced by Windows based on what people are opening in the file browser. So like me right now, this folder that I have opened, this is traced in Shellbags. Now, this is stored in a user class hive. And the first thing we can do there is we can just look into the CSV. Let's see how we can open this. First, there's also a tool by Eric Zimmerman, of course, as well, which is called the Timeline Explorer. It allows you to look into CSVs like this. This is the Timeline Explorer. And this is already pretty cool, right? You can see that these are the folders that Luke Evans was opening or accessing while they were logged on interactively through their Windows File Explorer. Now, there is timestamps to it. And the most important ones here, first interacted, last interacted. And now that basically tells us a timeline of when they at least first opened it and last opened it for some of those. These timestamps are just the folder timestamps of when they were created, modified. That doesn't really tell us that they were accessed, but we can see now that this user was going through all of these folders while they were logged on. And some of them might be pretty interesting, right? Let me see if it makes sense if we start first interacted. Now a date, if you remember, March 12th. So prior, the day before, on March 11th, there was some heavy activity here. And this user basically accessed the Y drive. So Y is /corporate. That sounds a lot like a file share on this environment. Then there were in documents administrative, in documents clients, in downloads, Y/finance, Y/IT, Y/projects. Then again, there was a project folder on the documents, on the local document side of things. So maybe a copy of this one, since it happened literally right after. And then there's documents/personal/new, which is a folder called new, Y/HR, and so on. Then back to documents, personal, new. So these were all the folders that they were looking into. And then there's personal/out/corporate. Out doesn't sound good. Corporate is something we've seen before in the file share up here. And then later on, we see there's also a G drive, and /my drive accessed. I don't know if people recognize what my drive might indicate, but my drive is pretty suspicious in this. A pretty distinct name of what my drive could do or be used for. We might have seen that before in a lot of other places and be familiar with this. But we'll come across this in a little bit. So all of these things that this user accessed have timestamps with it, right? With last and first accessed. So if you just take first accessed and then we just copy this into our timeline because that's our first evidence, right? So I would go into my timeline here. And since I already have it in there, I just need to enable it. I just look into Shellbags. And voila. So here we have chronologically ordered this time. So everything on March 11 and 12 on this system by Luke Evans, most recently used time is this. And now we can see the first open personal, then Luke Evans personal, personal new, Y corporate, personal out corporate, my drive, new documents, and so on. So it is like jumping back and forth. So now we have Shellbags. So this is basically a first step. We know what this user did. Now, this is just the folders that we're accessing. So there's a lot of other interesting findings now. We know that obviously everything is technically anything here could potentially have been accessed by this user. Any folders and files in there, confidential information. If this all sounds confidential to this company, then we can say, well, they accessed it the day before. So there's potentially files somewhere. So we could try to find evidence of those files. All right, enough Shellbags. So this is basically all we got there. Let's see, there's a couple more artifacts that can tell what a user executed while they were logged onto the system interactively. There's an artifact that is called activities cache DB. And activities cache DB is basically, long story short, the Windows timeline. And that is for graphical, for the GUI, for the graphical user interface. So you can think about it, but actually it's right here, this one. If you open this, these programs that show up here are traced in the Windows timeline. And the Windows timeline can actually be, is called activities cache DB. And we have a parser for this to see what applications were opened graphically by the user and when were they in the background and when were they in the foreground and so on. So now we can actually open up this one. This is the activities cache DB parsed out for Luke Evans. So we can open this one and see what this user did, what was traced in the timeline based on what we've seen so far, what could be interesting. All right, so this is what it looks like. Let me sort this real quick by start time. So there's a start time. And it's already sorted by start time. So this is the latest latest activities to newest. So latest, before this user resigned, what happened? Hopefully it is big enough for everybody to read. So we can tell there's an executable. It traces the executables that were executed, the activity type, whether those executables were in focus, execute open. For Explorer, we even get a copy paste activity. And we can see even the documents that was associated with the executable. So WinWord, resignation PDF, for example. Can also see the file path for this. And we can see the time. So this is telling basically the entire user story of open programs and documents that they might have had open during this time. And if we start going through this from latest the last thing they did was obviously opening this WinWord resignation PDF. Then at March 12th. Shortly before that, there was a document, a doc X in this case, with resignation. So I guess this was the PDF, this was the doc X that was created. And then shortly before that, there's a bunch of other applications that ran. Certainly a great one if you see CCleaner in your executables on a system that somebody just left before they resigned. So CCleaner was opened from their installation directory. Before it was installed, it was executed from the downloads folder. Then we had Windows Explorer activity in focus. We have Windows Explorer copy paste activity before it actually it shows us Google Drive was executed from the program folder. And prior to that, it was executed from the downloads folder. So here's Google Drive setup. And before that, we have copy paste activity, Acrobat Reader, Slack, Acrobat Reader, And here's some documents that were opened by this user. Principal Production Manager, Blue Origin. So I guess the Terra Nova guy wanted to look over what's going on at Blue Origin. So there's a PDF and so on. You can see there's Slack, there's Zoom, there's Windows, there's Zoom. So we don't know exactly what was going on there, but there's a document minimizing the risks of hiring employees from a competitor. Great. Might be telling. Company policies, another supervisor role. All these things are pretty telling in terms of what was going on in the system. Creating those job role documents, Google Drive, CCleaner, letter of resignation. So this would all go in my timeline. And then if I put this in my timeline, let's see if I got it here, mixed with Shellbags, we can now see what was going on here. So for example, maybe let me do a thing here real quick. Let's add some color to better be able to read this. So here you go. So now we have, all these things such as those, there was probably regular or maybe suspicious activity where they created these documents, right? There were the job roles were opened and so on. Winword was opened, supervisor roles, company policies. And then this guy opened the personal folders, documents, personal new. Maybe they stored it in there. There's some correlation in terms of time for sure. Acrobat Reader was opened. And then we see all of a sudden there was the Y drive. So the share, the corporate share was opened. And then there was personal out corporate opened, which is equivalent to this folder. And then there was Google Drive executed. Google Drive started. Then there was Windows Explorer copy placed. Then the G drive was opened in my drive. It was in focus. And then it was, personal new folder was opened as well. And then the CCleaner was opened and so on. So now we already have a story of documents and of executables that happened after each other. All right, let's keep going. Activity cache database, pretty fun one. Now, what else could a user have done? There's some evidence of execution, right? So in this case, we have artifacts that trace every application that executes. There's quite a lot of them. The one that I want to be using today is just prefetch because that's a really easy one and the most telling one. So PECMD stands for prefetch. And those are the files that are being created whenever an executable is being executed on the Windows system so that Windows uses it to be able to execute it faster the next time. It's like cache files in some sense. But there's a lot of them, right? So all of these would be applications that have been executed, Acrobat Reader so many times and so on. So what we need to do is, first of all, sort by time. And then maybe let's just see if we can find whatever happened during the times that we're interested in. Well, there's still a lot. And then let's see how we can go about this one. So we have evidence of execution within this Luke Evans folder. So let's see what Luke Evans downloaded. And so we already have this one here. So within the Luke Evans downloads file path, we see that this CCleaner was executed right here. And we see that Google Drive was executed right here. And so on. So these timestamps are pretty accurate. So these are the files that are keeping track of when it was executed. I'll get into that in a minute because the great question is every artifact that shows traces of execution works a little differently, and being able to interpret those accurately is extremely important. So here's just a sample of it. But if I go through the entire list and just highlight all these things that I think that are interesting for me, I can put those into timelines too. So let me see if I have prefetch actually here. Oh, I do. All right, so now, and here's an interesting one. I have added prefetch. And now what I can see is that in between, there's the user opened up Luke Evans, personal something, and 7-zip was executed. That was not captured because it was not a front-end graphical application, but 7-zip executed before they accessed this system. So 7-zip, for those who are familiar with it, you can probably create an archive. Maybe there was something zipped. Then we have Google Drive set up. Then we have CCleaner execution timestamps. even more evidence of everything that we've already seen, plus a few more things that might have run in the background. If they use PowerShell, it would have been PowerShell execution. So this is certainly a great part here that we now might want to jump into looking into, well, is there any zip files that were created or deleted? But we still have this lead with our Google Drive, right? So let's jump into this one first of all. We know that if we had looked into the mounted disk, first of all, this is maybe what I can show you now. This user was actively, working within the documents folder and the downloads folder. In the documents folder, there's still this, we're able to see these, folders that we're familiar with. But in personal, there's the letter of resignation. But if you remember, there was a /out, there was a /new. These folders are gone, right? They're not there anymore. So now we could look into NTFS artifacts. That might be evidence of deletion of these artifacts. Or we could just see, more interestingly, if there is data theft, what might have been stolen. And if so, Google Drive is a great indicator here, right? So how can we look into Google Drive? And for this one, I just want to show you an approach that I figured out, I guess, while working this case. There wasn't something I've done before. But Google Drive does one thing. When you store Google, when you run Google Drive, you have a drive letter, right? You have a virtual drive letter. And this is not something that is captured through the data acquisition usually, because it's a logical drive letter. It doesn't exist physically somewhere. So what it does is, though, if you install an application such as Google Drive, it gets stored in the user's particular app data folder, such as just like so many other applications. There's Google Chrome installed and Drive. Drive FS is the location. And this is the configuration of Google Drive. And we can already see all these files were created on March 12th. So that's pretty telling. So Google Drive was obviously installed at that time. And there's a user ID. So every user gets an ID, and within this user ID, there's user-specific information. And this is where you can already tell things are getting interesting. I need a tool real quick. You can now start looking into these. So first of all, a lot of these, there's more information you can find out about it, but the most important ones I found out was the metadata SQLite database, first of all. And since it's an SQLite database, I'll just use an SQLite Explorer to drop it in there. And then let's browse through the tables. This database has tables, one of them called items. And even though we have no evidence of these files of what was exfiltrated through potentially Google Drive, we now are starting to poke into the Google Drive particular artifacts that can maybe hopefully tell us more. So there's IDs, and now we can already say, okay, IDs seem to be associated with files, because now we have each row a file. Two of them are folders. There's some PDF extensions, and then there's a zip file. And if we look closer, we can see that there's timestamps when this file was modified, when this file was viewed by me, date, and it was the name. Here's the name. So we can say, okay, this My Drive is a folder. Then in Google Drive, there was a folder called New, which was interesting. Then we have these files in here, PDF, 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 the ones that we actually saw before. And here's an out.zip. We did not see, we saw an out folder, but we did not see out zip. So this is important. This is something that actually is highly suspicious. It has file size, there's some data in there. Now let's see how we can restore this. And the most important part is understanding where Google stores data. If you cache it locally, it turns out that there is a content cache folder. Content cache contains a bunch of chunk folders, some of them empty, some of them not. Let's see if I can even find one that is not empty. And it turns out, well, there is just random, binary files in there. But if you open up those files, and just even a hex editor, text editor, you can see the magic headers. This is, for example, a PDF file. So that's pretty interesting. Now, I wonder if we could just parse through these directories, if there's potentially files we can recover, given, associating this with the SQLite database that we already have here. So we can actually recover the files and not just the metadata that we already know about. And for this, because I did not see a script out there, I used vibe coders, like some IDE and some vibe coding techniques in order to build a program that does it. And this is something I've actually just recently published on GitHub. It's out here. It's called Google Drive Forensics Extractor and Metadata Exporter. So let me parse this real quick, post this real quick. This tool just recovers and parses these kinds of things. So what you can do now is, and this is my final kind of thing here, we can parse out these artifacts that I just explored through the browser. Now, what I need to do is, getting back to the Google Drive folders and the tool, and then hopefully able to run it. Of course, it's a Python tool, so I need Linux. Let me get to my tools here real quick. So what you can do is here, we can use Python 3 to run drivefs recover. And it was completely vibe coded. I used to do software development a long time ago, but I didn't touch a single line of code here. This was just completely like telling, hey, parse this, parse that, and put it out, put it as an output. So we can parse the cache directory, we can parse the metadata file, and we can put it into a destination directory. So all we need to do really is point it to the source, which is, it's the cache directory. So in my case, I have it mounted in the file drive here. Users, Luke, app data, local, I think, Google Drive. Oh, yeah, that was right. And then this is the cache, content cache. Then we have a dash for the metadata file. And that goes into the same location. App data, local, Google Drive, drivefs user, SQLite database, and then we have a destination. I just store this in my analysis case folder. G drive, let's see what happens. Cool. So what it does is, it extracted files. It can read, based on the magic headers, PDFs, docs, zips, JPEGs, PNGs. It found 6 files, and it parsed the metadata SQLite. And let's see if we actually got an output here. If the demo gods were with me or not. We did. So what we have here is, this is the files, this is the output that we recovered from Google Drive. We have PDFs. So this is the PDF we just recovered. And most importantly, we have a zip file. And here's the out. And here's the corporate folder. And here's all the files that this corporate folder actually contains. So this is what this user created as a zip file, put it in Google Drive, and was hoping to exfiltrate through Google Drive. And now we recovered it because it was still part of the cache that was part of the system. So just a vibe coded tool. I think I actually messed up the metadata SQLite thing. So no worries, I have a backup of this parser. So this table, this is the metadata table that also should have been parsed. And I can show you that as well. If you open this up in Timeline Explorer, so this is just a table that we are seeing in SQLite earlier. This is the ID of the particular files. And then we can see file folders, file types, PDFs, zips, and then we have file sizes, and then we also have the files that were part of Google Drive, out.zip. And we even recovered out.zip because it was still in the cache. And if we open this, add this to the timeline, especially the last viewed, this is going to be even more fun because now we can see, well, we have Google Drive modified date. So this is just a file modified date. Does not mean that it landed on Google Drive. It's inherited date time. But we have the viewed by me date. So this is the last time the user saw this on Google Drive. And this is really cool now because right now we can see Google Drive was downloaded, Google Drive was executed, Google Drive, Windows Explorer got a copy and paste command, G Drive, My Drive was opened. All these files were last viewed in Google Drive. So now we saw all these files were copied in there is this, during this particular time. And then the C cleaner was run. And then a letter of resignation happened. And so we have a great story. Already there's more artifacts, of course, that we could have looked into. We haven't even touched on some of the file artifacts, but particularly the Google Drive thing, I think, was fun because Google Drive we come across a lot of times, and it's pretty straightforward. We just need to took a little bit of ChatGPTing to figure out the Google Drive structure, then writing the script, which is all online here too, and then ideally, if there's something in there, you can just run it on your Google Drive app data folder and cache and recover it from there. So yeah, I think almost right on time. But thank you very much, everybody. Appreciate the likes.
Yeah, perfect timing, man. That's
Yeah, I
fantastic.
think so too. Thanks.
As usual, man. You have a few minutes for questions that we can go over?
Yeah, of course.
Awesome. First one comes up from Arcus Honor, and they're asking, should I run Cape after or before RAM acquisition and after or before a disk image?
So the order of volatility usually says, right, you don't want to touch anything. You want to take the memory image first before you run any tools, right? Because technically that means you're tampering with evidence and so on. And that's like a trade-off. You need to make a best decision depending on the case, right? If you need to get something done fast and might not even have any legal implications and it's like a ransomware case and you just go fast and you just collect data, well, sure, you run it, but you will also see traces of your forensic tools being run on the same system. That happens, but if you want to go as clean as possible, then you ideally want to capture memory and disk images and everything in a way where you have as little traces as possible of your own activities if you can.
Thank you. I just put a link for the slides in the chat. You can also find the slides in the resources on Zoom or in the slides resources channel on Discord.
Yeah. Actually, before we wrap things up, I was going to point this one out because, if people want to know more about forensics training, we have stuff coming up, especially, with you guys in the Blue Team Summit. In 2 weeks, we are actually doing this kind of Windows forensic stuff for 2 days. The workshop is called Practical Windows Forensics. I'm happy to be back at the Wild West Hacking Fest to do a ransomware attack simulation investigation as well in Deadwood in a couple months. And then, more of those Windows trainings and things along those lines. You can find on Blue Cape Security as well, do some more workshop there. But happy to have people join us in 2 weeks from now. If you can make time, will be some Windows forensics fun for 2 days to go through, the forensics cheat sheet that you saw out there, and the basics, the foundations of everything you need to know when you perform Windows forensics.
Sure. And I just put a link to the Blue Team Summit in the chat so you guys can check that out. Do you have any good books for forensics or IR that you can recommend?
Yeah. Generally, I think, what was it called? Like Kevin Mandia came up with like basically the Bible of digital forensics and incident response, maybe like 10, 15 years ago. I have to look up the name, but it's basically something about incident response. So yeah, Kevin Mandia book, I would say, is a good starting point. And then there's Harlan Carvey books. He's pretty famous in the industry who does like a bunch of deep dive forensics, especially into Windows artifacts, registry hives. That's the good ones to know. I like to, a lot of times I just like to build my labs, attack the labs, and explore those artifacts on my own, use the different tools because tools have different outputs sometimes and different ways of how to handle things. So, this case that you saw there was basically simulated through just doing something that a user used to do that I saw in a case once. just all the things, and then I just took images and started investigating those. It's also part of a investigation lab that we have out there. But for those who want to, learn more about it, doing those things yourself, using some cheat sheets, can get you pretty far too.
Thank you, sir. Jelly Beanster is asking, what kind of actions or things does Arsenal Imager do better compared to other programs?
So as far as I remember, it actually mounts the image, the logical drive. It mounts a real logical drive, so you can actually access certain like folders that otherwise would have permission. You would have permission issues. Um, you can actually even access them through virtual drives. So it's like it's like a real logical drive that is mounted to your system that allows you to sometimes run parsers across locations that you wouldn't be able to do so otherwise. So, for example, if you use, I think, a 50K imager to run Cape, Cape doesn't even start because Cape is saying, no, we don't want FTK imager, we can't do that.
Thank you, sir. Clem is saying, perhaps this was covered, but do you sandbox or attempt your forensics in an isolated network to reduce chance of an insider creating some sort of time bomb or trigger that might fire when certain forensics measures are run?
Um, well, it kind of comes with, detonating malware and so on. If you have sandboxes for these kinds of things, for sure. If you just mount those images, obviously you just when you want to use a dedicated forensic lab for this. Usually there shouldn't be anything happening, but if so, of course, you always want to make sure that you have it isolated and be able to wipe it afterwards, and it doesn't affect any other systems and so on. So, yeah, it depends on the case and what you're looking into.
Thank you, sir. Yeah, somebody just got shout out to the Hall and Osint shirt. Gotta represent Hall and Osint. He won the Vishing um uh the Vishing thing at DEF CON last week. Vinny is his name. So yeah, shout out to Vinny for winning the Vishing competition at DEF CON last week. And thank you again for the t-shirt because it's pretty cool. And there was another question I had pulled here for you. From Little Samurai, they're asking, are there any other similar tools to Google Drive FS for other cloud storage products like Dropbox or OneDrive, etc.?
Um, Honestly, I'm sure there is. Like, we can just on GitHub, there's a whole bunch of tools, scripts for these things. It's nothing crazy that you need. Of course, some, larger commercial forensic tools and applications probably have those things included, obviously. So I think even Autopsy can do that. But if you want to go the fast route like this, like I did, just quickly parsing, I'm sure you can find scripts out there.
And going through.
So I saw somebody was asking about the courses. So yeah, you can take actually the Windows Forensics course is part of the Antisyphon catalog. So the on-demand version, you can take that too. We are going to do it live, the Blue Team Summit. On bluecapesecurity.com, you can, there's not like individual courses. It's basically the journey of the course, the labs, and an exam that you can take there in terms of forensics. It's not just the individual course there anymore. So it's more like lab-based and hands-on training and validation. But yeah, a bunch of workshops coming up too, and I'm very excited about those.
I just post a link to your class that's coming up here in the chat so you guys can check that out. I had
Oh
a
yeah,
few questions from people asking if you have a Discord by chance. Do you have your own Discord server?
yeah, we do. Blue Cape Security. Let me let me see if I can get you a link somewhere. I'm sure we have it on the homepage.
Thank you, sir. If y'all have any other questions, now is a good time to put them in the chat.
Oh,
Otherwise, we'll give you some free time back for the day. Yeah, you will get you should have a link in the for the recording in your emails.
yeah. Hope everybody was able to get the links, try to post as much as possible. But yeah, if anybody has questions on that, feel free to hit me up. I'm on Discord. We have Blue Cape Security on Discord. I'm trying to keep track of the Antisyphon Discords, but there's only so many things I can, trace and follow. So yeah, just hit me up, and I'm happy to
Awesome.
get back to you.
Thank you. Yeah. So if anybody has any other questions or wants to follow up with Marcus, please consider joining us at the Blue Team Summit for his next class or join his Discord server, connect to him with him on the social medias. I'm sure be happy to help you out any way that he can. It's always a wonderful experience having you here, Marcus. Really appreciate you just taking your time out of your day to share your knowledge with everybody. It's very much appreciated from us and everybody here in the audience, as you could see from the emojis and all the thank yous, man. So thank you so much, man. We really do appreciate you.
Very much appreciated too. Thanks, Zach. And I'm looking forward to seeing everybody in person soon again.
Yeah, absolutely. So again, thank you everybody for joining us. We do these every single Wednesday, so join us next week for another Anti-cast. We hope to see you there. If not, join us for maybe a Black Hills webcast on Thursdays, because we do those as well. Otherwise, until next time, take care, everybody. See you later and have a great day. Bye-bye. Take care.